Hello everyone, exciting step. As you know, we're going through a build of a self-driving car in very small increments. So we truly biting the elephant one very small chunk at a time. Today we're talking about steering. And if you open my tutorial 4 in my GitHub repository and you scroll to the very end, the final result is here. So you can just run this code, which says full code. You run it. As you can see, it starts the car and sends it along the navigation route. And this is the view from the camera above the car. As you can see, it's targeting certain waypoint in the navigation, and it's showing you the desired or steering angle it's applying to maintain the car along the navigation route. How cool. It works. Yeah, just ran the red light. As I told you before, this is very crude. This is just, ignoring everything else, doing two functions: maintaining speed, which you've seen before in the previous video, and steering the car to get to the next waypoint. And as it does it, you need to go through and flick to the next point, obviously. So that's what you'll see in the detailed code. Okay, let's just wait until it's done and finished. We go back to where the end of the route is. Yep, the car is nearly there. Done. So it needs to stop. That window with the camera disappears and it's all working fine. Gee, it took me a while to get this far, and I suspected the steering thing would be quite simple, but whoever needs to go into details, I'm encouraging you to just go step by step. That's why I've done it via Jupyter Notebook. So the bits that you have here are pretty much as before in the previous tutorials on the basic navigation and just driving the car at a straight at a certain speed. Where I would like you to go through and read a little bit is, I was just trying to work out the geometry of steering and angles and everything. And this, for example, is a supplementary code where the car, you just start the car and it drives in autopilot, and you can stop it at any time by pressing Q, and you can check the angles. You can get the things from that point where the car is, some telemetry. So it's that. And what I was playing with is this function called get forward vector. And that's essentially where the car is facing. Now, this bit here is also allowing you to show where particular waypoints are. So, for example, if we come back here, you can see that there are some blue things here that show you some numbers. So it's this 25 means it's a waypoint 25. And I was figuring out initially a lot of things from here. Now, interestingly, as we now go into detail, we may as well just start the car from the beginning, which is the same code as before. So we just initiate the car in our normal starting point or spawning point. And then as we scroll down, this is where we start playing with these things. So this is our get forward vector function that I'm using. And it's actually available for waypoints as well. And as you read some of these in more detail, you'll find that, well, it could be used maybe later. Some of you may want to experiment how to get forward vectors from the waypoints. But as I was getting it from waypoint 25, essentially the vector in that point shows you that direction, right? So it only, obviously, it can only relate to the route itself, but you can sort of use it as an angle to orient the car. However, what I found out, the nutshell of steering and keeping along the navigation route is a couple of things, or three things. Thing one, where the car currently is, like in this spot now. The second one is the exact location of the waypoint that you're trying to go to. And obviously you can't just go straight to 25, so it's a separate thing that you'll see in the code. But the location of the car and the waypoint is essentially define your desired angle, or where you would like to be. So that's the first 2 points, the location of where you are and where you want to be. And point number 3 is the angle that the car is currently facing. And for that, you can use this get forward vector function from the car, like it would be, for example, vehicle.getTransformed.get forward vector. And that vector is it will have X, Y, and Z element. So essentially it's direction in all 3 dimensions. So obviously we're not interested in dimension Z because we're not steering the car up or down. We can only steer the car in X and Y. So therefore we ignore dimension Z in here. But this tutorial is sort of stepping you through like some examples. So for example, from here to waypoint 25, you can see it walks you through what all of those values are, like where the car is, where the waypoint is, X and Y coordinates of the car and the waypoint, and how to get certain angles. I also have some illustrations here where, for example, if the car is located here and our waypoint is there, which is like this situation here, essentially at this point, the angle that we need to take is negative 39 degrees to waypoint 25. Not that we want to take it straight, of course, as I said before. But these are the kind of calculations that you need to go through. And it's just this tutorial, when you get into it, goes into more detail. Because this stuff is the basics. Like, you need to know this simple geometry of how to know where you are, where you want to go, and figuring out the angle essentially to get there. And as you see, it works. So I highly encourage you to read and try this for yourself. Interesting observation though, I found by value of vectors, I found that the y-axis is actually going this way. So it's increasing in that direction, which is not the same as in maths, but it's probably very similar to how pixels are done in digital imagery, because you've got the like width and height sometimes mixed around, and you know the height is actually going in this direction as well. Maybe that's why, but I found it's quite strange. Then I've got another example where I use another waypoint in the car from the route, which is located there, and I move the car to that spot, and then I'm trying to measure this angle. And using my formulas that I showed you before, I actually get an angle of 78 degrees. And what is interesting is when you calculate the angles using this approach here, is because you divide by x, or the difference in x between the 2 locations. That's why the angle that you get as part of this is always in relation to x-axis, right? Which is I found interesting. So the next thing that we need to do is we need to figure out how we can compare the direction of the car to the direction of that where you would like to go, like for example to waypoint 25. And for that, because the car direction is a vector, get forward vector, so the next step of this is explaining how we need to convert from these deltas of, for example, 16 meters to the left and 19 meters forward, how do we need to, what we need to do to convert it to a vector. And this little section here describes how you do it. And essentially, it's a basic geometry to do with right triangle, and the square of sides equal to the sum of square of sides equal to the sum of squares of hypotenuse. It's that simple. It's just the formulas look a bit strange, but if you step through them slowly, you'll actually get there. And then once you get the conversion, which is this formula here, how to get from deltas in x and y coordinates to a vector, which is this, then you can use a simple, I just looked it up on the internet. I don't remember tangents and all the other functions. For that, I always refer to internet. And that's essentially the thing that gets me the degrees between, one vector and the other vector. And I define it as a function. And then I test it, and I get quite reasonable outcomes. Like, for example, in this case, to waypoint 25, it gives me, these are the values here, minus 39 degrees, which is great because it turns me to turn late. And I also, left rather. And then I tested on the mirror reflection of waypoint 25, which is kind of located here, and it gives me a positive angle of 39, which is great. And then a couple of other examples, like for example, to east to north, and in the same direction is 0, and between east and west you get minus 180, so it all makes sense. Now we just define the next function that calculates all that using, the vehicle position and the vectors and well, just the location, and from that you get the thing. But at the very end, you also need the direction of the car, which is just here, and then we get the angle between. We're using that function that we defined here between essentially where we need to be from facing the the difference between the delta between the vectors of that and the vector of that, which is where the car is facing. And again, we always use where we want to be first as arguments of the function. So bang, we get our angle. And then if we test it, for example, here, if we test it against waypoint 125, it gives us minus 99 degrees, which is exactly what we expect. So great, it all works. And then there is a section here that also needs to figure out, because what we put in the function of applying control is values between -1 and +1. And how do we get there from degrees? Well, a couple of things here. One, we need to decide what the maximum angle of the car steering should be. And I would say it's 40, because I used this and I looked at the car. The car is actually, when you give it -1, it turns the wheels left at like 80 or 75 degrees, which is unrealistic. But it told me that the maximum, like when I give it -1, that equals to 75 or -75. And therefore, besides just applying 40-degree maximum, which is just my number from, like I don't even know what the real cars do in this case. It doesn't matter for this exercise. But because the maximum is 75, every time we need to turn to a certain degree angle, we need to divide it by 75. So for example, if we want to turn 20 degrees to the right, we need to divide it by 75, and that gives us 0.26. And that's what we need to put into apply control function when we actually need to use that steering angle. So that's it. And then this last bit is just testing everything together. And here I use few things. Well, first of all, you need to kind of track your navigation points as you go through them. And this is what's happening here. Well, first we start with, we don't try to reach to the very first waypoint. I just picked 5, so it's sort of roughly around here. But then, because the car will start moving, we'll need to check if, let me just make this bigger. So what I do here is, if I get within 5 meters of the waypoint that I'm targeting, I'm switching to the next one, because the car will be moving fast, and I just make sure I don't get past the navigation point from which I get a direction to go back. So the idea here that navigation route should always be forward. This is kind of you tracking how you progress along the route, okay? So that's one thing that we put in this sort of looping, the normal looping thing that we saw before in the drive straight tutorial. Another thing we need to do, and that's what caused me to spend quite a bit of time figuring it out. So when the car was getting there and was facing the opposite direction from where it is now, so it was progressing nicely along the route. However, at that point, it started returning weird angles, like minus 350. So, and for that, I created this little check where the values, when they get very close to those 360 sort of, which is pointless, I deduct or subtract those 360 to get back to normal angles. The first thing is that I'm doing that. The second one, I'm also trying to enforce what the maximum steering angle is. And as I mentioned before, it's 40 degrees, so that it's this bit. And then I just express it as a fraction of maximum 75, that the car actually can turn at minus or plus 1, and then gives me the actual value that I need, or the fraction that I need to put as a steer input. And that's what happens here, that steer input is defined finally, and then, you know, the loop continues. That's it. I encourage you all to go through and read these and try it step by step. It's quite interesting. Yes, I was good at school with geometry, but it's been a few years, so unfortunately you have to go to very fundamental sometimes. But to get this right, you need to go to very fundamentals. I hope you enjoyed it. I'll see you with the next tutorial very soon. Thank you. Bye.